People cannot simply solve this relatively easy geometry problem that is circling online, and they're always sending me text messages asking me, can I solve it? But it's super easy.
If the outer circle marked in red is a unit circle, find the radius of the smallest circle in the picture.
And while you're pausing this video trying to think about this problem, let me explain you why we're even solving it on this channel, usually reserved for Fabric of Life, a show where we try to answer a little bit more complicated questions than simple math problems. Well, May is a month of mathematics, and while we will try to solve mathematics or to use mathematics in our everyday life, May is the time of the year when we try to shine a light on some simple problems, encourage people to involve themselves a little bit more in mathematics. And why is that important? I will explain you after I show you solution for this extremely simple Japanese math problem.
Now, you remember this picture, right? Well, let's see one interesting triangle inside all of those circles. I'm going to draw it right here. As you can see, there is 90-degree angle here, so we can use later Pythagoras theorem. But let's denote the radius of the smallest circle as r. And let's imagine that the medium circle is now the unit circle, so I'm going to write everything like 1, 1, 1, etc. And then we can use Pythagoras theorem on this very triangle, and we can say like 2 squared plus 2 squared equals 2 plus 2r's squared. And from there we get the radius of the smallest circle compared to the medium one. It's square root of 2 minus 1. So the ratio between radii is therefore 1 compared to square root of 2 minus 1. Now we have the radius of the largest circle is the sum of the diameter of the medium circle and the radius of the smaller circle, as you can see here in the red line. So we can write as that is like 2 plus square root of 2 minus 1. This is the small r, and that is equal to square root of 2 plus 1. So the ratio between all three circles is therefore square root of 2 plus 1 compared to 1 compared to square root of 2 minus 1. So we have a ratio between the big circle, the medium circle is the 1, and the smallest circle. But now we want to focus on the biggest one and the smallest one, and to find the ratio between two of them, to focus on the ratio between two of them. And if we divide both of those sides with square root of 2 plus 1, we're going to get 1 compared to square root of 2 minus 1 divided by square root of 2 plus 1. And this actually is going to be the radius of our smallest circle. It's going to be square root of 2 minus 1 divided by square root of 2 plus 1. And if you want something more mathematically, aesthetically pleasing, you're going to multiply both of those sides of division with square root of 2 plus 1. And then we're going to get 3 minus 2 multiplied by square root of 2. That is going to be the diameter of the smallest circle when the biggest circle is the unit circle.
Well, some of you might ask me now, even if I was able to solve this simple geometry problem, does it have real implications on my everyday life? How I can actually benefit from knowing something like this?
Well, there is geometry in humming of the strings, there is music in the spacing of the spheres, said Pythagoras of Samos, the ancient Greek philosopher and politician whose teachings influenced the philosophies of Plato, Aristotle, and through them, Western philosophy.
I can spend, if not weeks, then months, sitting here trying to explain you the importance of geometry in our everyday lives, how it can influence you to look for a shorter way when you're walking through the city, how it can help you measure foods and liquids in your meal preparations, but also how it is used in modern movies to give us sense of reality. From sensors in our smartphone to everyday objects we use, geometry informs our purpose and beauty that we see in the world. Without geometry, the most astronomical findings would not be possible. But what is even most important, if everybody was able to solve this simple geometry problem, less people will think that Earth is flat.
And speaking about the science, geometry and Earth that is not flat, a couple months ago I went to Italy to rediscover the greatness of Leonardo da Vinci. I followed his steps in order to figure out, is there a possibility of the modern Renaissance man? This episode is absolutely amazing and we had fun making it, so I advise you, I'm going to link it down below. If you didn't watch it, please give it a try. See you next week. Until then, stay tuned and curious, and don't forget, libraries still exist.